Hello, this is question 2 from the 2012 Extension 1 past paper. It's from semester 1 at Barker College. And it's a question that deals with the graphs of inverse functions. So the main thing, it's got a big fancy name, inverse functions, but one of the most important things to remember, and all that it means is you swap your x's with your y's. So you put your x's where your y's were, and your y's where your x's were. But more about that in a minute. So I'll just read the question out for you now. So it says, the quadratic function y equals f of x. So that's this thing. So this is a parabola because it's a quadratic, which means that it's symmetric, is sketched above. For an inverse function of, so this bit won't make much sense for the time being, but it says, for an inverse function of maximum domain to exist, the restriction needed on y equals f of x is. So more about what that last sentence means in a minute. But what I'm doing over here to the right, and sorry I've done a bit of graphing before we've started, is that I've just drawn this graph again in dotted lines here. And what we're going to do now is, this is the graph of f of x, this dotted thing over here. And what we're going to do is we're going to draw the graph of the inverse function of f of x. So what we're going to do is, so this is, when you're going from the function f of x to its inverse function, here's a handy trick. So you find a point. So the blue point that I've written here, 4, 0, is on it. So a point that will be, its corresponding point on the inverse graph will be this point here, which is 0, 4. So you just, like I said, you just swap the x's with the y's. Couldn't be easier. So another point, which was on the original graph, f of x, was this bad boy, this 2. So it was initially 2, 0. So what we're going to do is just swap the coordinates around to 0, 2, and you get this green point. And now we didn't even get given this point 3 minus 1. Oh, just quickly, we know this 3 because it's symmetric. Parabolas are inherently symmetric. So this point here, the midpoint will be at 3, just by the property of symmetry. And we don't know what this is down here. We could sub it in if we knew the equation of the graph. But I'm just going to say, just for explanation's point, say it is minus 1, okay? So this purple point, 3 minus 1, we definitely know it's 3, we don't know this y corner, but I've just had a guess and say minus 1, will get shifted to minus 1, 3. So that's when so I've just swapped those around. And now what we're going to do is, we're going to draw this inverse graph. So if it's going through these 3 points, it starts here and it's coming around, it's going to go back out, you get a pretty good idea of what it's going to be. So the inverse graph is going to be something like this. Beautiful. So that's the red arm, and I'm just going to draw this green arm down here. Beautiful. So sorry, there's a lot going on in this graph. So this graph here with the red arm and the green arm, that's the inverse graph. So that's the graph of inverse of f of x. So what I'll just quickly do is I'll just scroll down because there's an awful lot going on over here. So I'm just going to draw that again. So we had this part here. So it's a parabola on its side. And then this green arm we had was this puppy. Beautiful. So now so we've got the graph of the inverse function of f of x down here, and it said this thing here about this last sentence about restricting domains. So what's that's on about is that I'll quickly talk about the definition of a function. So a function by definition is something that passed the vertical line test. And what I mean by that is, when you draw a line straight, a vertical line at any point, it's only going to cross the graph once. So here it's only crossing once. If I go here, it's only going to cross once. Anywhere on this graph, it's only ever going to cross once. So it passes the vertical line test. So tick, she passes, which means it's a function. Beautiful. Now, say on this blue sucker, I've written, so let's see if this one passes the vertical line test. So here we only cross once. Here we go, we only cross once. Here, dramas. We're crossing more than once. 1, 2, 3. So because it doesn't pass the vertical line test, she is not a function. So it's not a function, and the definition of something that's not a function is a relation, but you never really need to know that. So, not a function. No good. So, now you can tell this thing. Does this thing pass the vertical line test? Well, obviously not, because if we draw a straight line straight through here, it passes twice, so it's not a function. So to be a function, what we're going to have to do is restrict this thing's domain, this original function that we had, and then take the inverse, and then we'll be left with a function. So say we only take the domain of this blue arm just here, right? So x is greater than or equal to 3. What we're going to do is, when we take the inverse of this point is still there, and this point is there. So we're just going to end up with this red arm. And if we just end up with this red arm, by restricting the fact that we're only using the domain x is greater than or equal to 3, we're only going to end up with this arm here. And what I'll draw is now, I'll just go down the bottom, scroll down a bit. So, sorry, I'll just draw up a quick little graph. Beautiful. Red axis this time, because we're in the mood for something exciting. So, if this is what we had, so we just had this part of the... Oh, what am I doing? So, I change that to red. And I'll do a little... Sorry, having some technical issues here. Beautiful. So, if I've just got this part of the graph, then this will pass the vertical line test, because it's not going to cross more than once. So let me say that again, because we got bogged down in some technical issues. So just by restricting the domain of this original function by x is greater than 3 only, we're only taking this blue arm. And then when we take the inverse, we're not going to get this green arm anymore, and we're only going to get this red one. Beautiful. And then because we've only got this red arm now and not this green one, it's going to pass the vertical line test. And so for an inverse function, something that does pass the vertical line test because it's a function, the maximum domain we need to have is for x to be greater than or equal to 3. Beautiful. So you might ask, why couldn't we have x is less than 3? Because if we had x is less than 3, then we'd only be left with this white arm. And then what we would have done is, we would have taken the inverse, and then we just get this green arm here. And sure, that would also be a function, but x is less than 3 wasn't on here, so it's just going to be x is greater than or equal to 3. So that's why it is C, and not x is less than or equal to 3, because that wasn't an option for us. So I hope that explanation of this question regarding inverse functions is clear, and I'll see you in the next one.